One tiny change in brightness, and your circuit instantly switches. How? Hey guys! In this video, I'll show you the simplest way to build a reliable light detector using only a 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 2 alligator clips, 10 jumper wires, one 10 kilo ohm resistor, one 22 kilo ohm resistor, one 4.7 kilo ohm resistor, a 100 nanofarad ceramic capacitor, one 10 nanofarad ceramic capacitor, one 10 microfarad capacitor, a 9-volt battery buckle connector, a 9-volt battery, a 5-watt speaker, one 555 timer IC, a 100 kilo ohm potentiometer, an LDR or light-dependent resistor, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor into pin 2 or trigger in pin 7 or discharge. Bend the ends of a 22 kilo ohm resistor. Insert a 22 kilo ohm resistor into pin 7 or discharge and pin 8 or VCC. Insert a 100 nanofarad ceramic capacitor into pin 2 or trigger in the negative rail. Insert a 10 nanofarad ceramic capacitor into pin 5 or control in the negative rail. Insert a jumper wire into pin 4 or reset in a few rows below the 555. Insert an LDR or light-dependent resistor into the same row as the jumper wire and the positive rail. Bend the ends of a 4.7 kilo ohm resistor. Insert a 4.7 kilo ohm resistor into the same row as the jumper wire and a few rows below the jumper wire. Insert a jumper wire 2 rows below the resistor and the negative rail. Insert a jumper wire 2 rows below the previous jumper wire and the negative rail. Insert a 100 kilo ohm potentiometer into the same rows as the jumper wires and resistor. Insert a 10 microfarad capacitor into pin 3 or output and a few rows below the 555. The positive terminal is in pin 3. Insert a jumper wire in the same row as the capacitor. Attach the other end of the jumper wire to an alligator clip. Insert a jumper wire in the negative rail. Attach the other end of the jumper wire to an alligator clip. Connect the alligator clips to a 5-watt speaker. Connect both ends of the negative rails with a jumper wire. Connect both ends of the positive rails with a jumper wire. Connect the 9-volt battery buckle connector to the 9-volt battery. It's time to connect the power supply. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. We have successfully completed the circuit. When there's no light, the speaker stays silent. As the light increases, the speaker begins to produce a tone. You can control exactly how much light it takes to trigger that sound. Simply turn the potentiometer knob to adjust the sensitivity, allowing the speaker to react with even less light if you want it to activate sooner. Let's dive into the circuit and break it down step by step. This circuit turns a 555 timer into a simple light-sensing tone generator. The pitch of the tone can change depending on how much light the LDR detects, and the potentiometer lets you fine-tune the sensitivity so the sound activates at the exact brightness level you want. The 555 in this design is used in a stable mode, meaning it continually oscillates and generates a square wave signal. The two resistors R1 and R2 form part of a voltage divider that helps set the trigger and threshold voltages for pin 2 and pin 6. Capacitor C1 stabilizes the trigger pin by filtering out noise and preventing false triggering. As the capacitor charges and discharges, the 555 repeatedly switches states, output high, then low, creating an audio frequency signal on pin 3. The LDR and the resistors on the right side, R3, R4, and the potentiometer P1, work together as a variable voltage divider. When light hits the LDR, its resistance decreases. When darkness increases, its resistance rises. This constantly changing resistance shifts the voltage feeding pin 4 and the node going to R4 and P1. Since pin 4 must be above about 0.7 volts to allow a normal operation, the brightness of the light effectively decides whether the 555 stays active or shuts off. More light reduces the LDR's resistance, raising the voltage and ensuring the 555 stays on and oscillating. Less light drops the voltage until the reset pin disables the chip, silencing the speaker. The potentiometer P1 is a sensitivity control. Turning it changes the lower half of the voltage divider, letting you choose the exact amount of light needed before the circuit produces a tone. R3 and R4 act as stabilizing resistors to limit the range and prevent extreme voltage swings that might make the 555 behave erratically. On the output side, pin 3 sends a square wave signal into capacitor C3, which blocks DC and allows only the AC audio signal to reach the speaker. Because the 555 can source enough current at 9 volts, no amplifier is needed for a small 5-watt speaker. C2, connected to pin 5, keeps the internal reference voltage of the 555 stable. The 555 handles all the timing, the LDR handles the sensing, and the voltage divider plus potentiometer controls the sensitivity. The entire circuit is simple, reliable, and a great demonstration of how the 555 timer can be turned into a light-activated audio generator. I hope this video has shown you how to make a light detector with a 555 timer IC. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Don't miss it. Click the link in the description to get yours. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.